Hi guys, welcome to another episode of my class. In today's class, we are going to be discussing how we can determine the group, period, bond pairs, lone pairs, and unpaired electrons for any neutral atoms. So if you want to determine all these things that I mentioned in the simplest way, like trick to determine it, that's very simple if they ask you inside the class or maybe you are having any exam. So this is the simplest trick that we can use. So let's get into it. So the first element that we have here is carbon. Carbon, so carbon has the atomic number of 6 if you count it from the element of 1 to 20 or from an element to 1 to 30. So the counting of number is correspond to the number of the electron, number of the element that particular element belong to. Like for example, now if you're having hydrogen now, hydrogen belong to group 1, it belong to hydrogen has one atomic number. The next one is helium. Helium has 2. The following one is lithium. So lithium will be 3, like that. Beryllium, boron, carbon, like that. So now the carbon has 6 atomic number. It has 6 atomic number. So it has 6 atomic number. So now that means we are going to draw the shell for 6. So this is what we call the shell. So like this, you are going to write in like this. So this is what we call the shell. If you open your chemistry textbook, you will see, you will notice something like this. So all these things, this cycle, we call it shell. So now, let's now do for carbon now. So carbon is the first shell will contain 2 electrons. So hydrogen, helium, make 2. Hydrogen, helium, lithium, beryllium, boron, carbon. So you make sure that you first put each electron to the 4 corners of the circle before you continue to distribute the remaining electron. So it means that this particular element belong to group what? It means it belong to the group for it. So for you to determine the group now, you will now count the number of electrons that is present in the outermost shell. So it means that we have, let's count the number of electrons that we have in outermost shell. So here we have 1, 2, 3, 4. The shell that is outside, we have 2 shells there, 1 and 2. We have 2 shells. So the shell that is outside, you count the electrons that are located outside. So that electron will give you the group that the element belongs to. So it belongs to group 4. So now you will now count the shell that we have there. So we have 1 and 2. So this one will give you the period. So we begin to period 2. So to now determine the bond pair now. The bond pair means that the elements that the atom bond to. And this, what we are talking about now, it's the neutral atom. So you get it now. So that means the bond pair now equal to 0 because it is a neutral atom. This bond pair is going to be 0. So the lone pair, this lone pair is going to be, so for lone pair now, lone pair is going to be 0. Lone pair means the electron that are joined to if you see any electron that are to like this means we have lone pair. So and after that, the unpair now. So unpair electron will now be 4. So these are going to go for it. So the second one is let's explain this. So the second one is for the nitrogen. So the nitrogen has atomic number. We can't see hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen. It has the atomic number of 7. That means we are going to make 7 electron 1. The first shell will contain 2 electrons. Sorry. The first putting it one after the other. 1, 2, 3. Sorry, let's start again. 1, 2, 3, 4, 5, 6, and 7. So now the group that it belongs to now, for the group, it means it belongs to, if you can't get, for the group, you count the number of electrons in the outermost shell. 1, 2, 3, 4, 5. So we have 5 electrons in the outermost. This is it. 1, 2, 3, 4, 5. So we have 5 electrons in the outermost shell. So it means it belongs to group 5. So for the period, so we count the number of shell. For the period, we count the number of shell. So we have the first shell and the second shell. So it has 2. It belongs to period 2. So for the bond pair, remember, it is a neutral atom, no electron bond with it. So the bond pair equal to 0. So the lone pair now is going to be the one that had joined together. Total, the electron that joined together like 2, 2 like this. So they are the lone pair. So the lone pair is 1. So you can't take it as 1. So this is the lone pair. This is the lone pair. This is our lone pair. So we only have a single lone pair. So after that, the ampere now, ampere is 1, 2, 3. We have 3 ampere electrons. So these are the ampere electrons. So this is ampere 1, 2, 3. So we have 3 ampere electrons. This is for the nitrogen. So let's go for the oxygen now. So for the oxygen, this is symbol for the oxygen. That's atomic number of 8. The first thing is the atomic number. So we now go ahead and make the shell. So after that, let's make the shell now. Shell is the first shell will contain 2 electrons. The second shell, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. So we now stop because the electron we have already reached 8. So you now go ahead, you fill the group that it belongs to. You count the number of electrons in the outermost shell. You count it, we have 1, 2, 3, 4, 5, 6. So it belongs to group 6. So the period that it belongs to, you count the shell, 1, 2. So we have 2. So the bond pair, remember what I said? The bond pair is always 0 because this is a neutral atom. The bond pair will be 0. So for the lone pair now, lone pair will be, lone pair will now be, so let's count the lone pair. Lone pair is this. We only have 1 lone pair. We have 2 lone pair. We have 2 lone pair. And after that, the next one is the ampere How many unpaired do we have there? Let's see. So let's count. 1, 2. So unpaired electron is going to be 2 also. Because if you can't see here, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. Can you see now? So 2 electrons that are joined together is for the lone pair. So we have 1, 2 lone pair. For the unpair, we have 2. So those ones that are not paired together, we have only 2. So the period, we are going to use the shell, the group. You count the number of electrons that are present in the atom shell. So let's go to the next one. So the next one is fluorine. The next one is fluorine. Fluorine has the atomic number of hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. So you count it like that. So it has 9 atomic number. So it has 9 atomic number. So you get that means we are going to distribute 9 electrons here. So the first shell will contain 2. So the remaining shell will now be distributing it one after the other. 3, 4, 5, 6, 7, 8, 9. So you now stop. So now you now determine the group. So for the group, you count the number of electrons that are present in the outermost shell. We have 1, 2, 3, 4, 5, 6, 7. So it belongs to group 7. For the period, you count the shell. We have 2 shells there. Can you see? We have 2 shells. We have to. This is the first shell, and this is the second shell. So we have 2 shells there. So after that, after the group, after the period, we have the bond pair. So the bond pair will always be 0 for any neutral atom. Bond pair will be 0. So the lone pair now, it is lone pair. So it is lone pair now. You now check it. The lone pair means the electrons that appear together. Electrons that appear together. Let's check the electrons that appear together. So this one and this one is paired together. Another one is paired together. Another one is paired together. That means we have 3. We have 3. We have 3 lone pair. So unpair now. For the unpair, we have how many unpair? We have, so we check it. We only have 1 unpair. 1 unpair electron. So the next one is sulfur. So we have already determined the group for fluorine now. So fluorine has belong to group 7, period 2, bond pair is 0, lone pair is 3, and then unpair is 1. So let's take a look at the last question that we have here. So we have the sulfur now. So sulfur, so let's draw the shell. So don't forget the first one will contain 2. So hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So you do another shell. So after neon, the next one is the sodium, magnesium, aluminium, silicon, phosphorus, and then sulfur. So we have already done that now. So 10, 11, 12, 13, 14, 15, 16. So it means sulfur has 16 atomic number. So the group now that it belongs to, so you count the number of electrons that are present in the outermost shell. 1, 2, 3, 4, 5, 6. So it belongs to group 6. So for the period, let's check the period that it belongs to. You count the number of shell now. count the number of shell. This is the first shell, the second shell, and the third shell. So it means belong to period 3. So the bond pair is a neutral atom. The bond pair now, the bond pair is 0. So neutral atom means that the atom that doesn't bond with any other element. So for example now, sodium now is a neutral atom. You can't compare it to when you have sodium 2 like this or sodium minus 2 minus. So you get. But we are going to do that maybe probably in my next video. So we have determined the bond pair. So for the lone pair will now mean that the electrons that are lone pair means electrons that are bound together. If you check it, we have how many? We have 2. 1, 2. The lone pair is 2. While the unpair, those ones that do not bond together, we only have 2. 1, 2. While the unpair equal to 2. So that is all for today's class. If you are new to my YouTube channel, so kindly help me to subscribe to my YouTube channel. So in order for you when we post another video like this. So in the next class, we are going to be talking about how we can determine the lone pair and bond pair of a compound, of a molecules, when two atoms are joined together to form a molecules. Because all these ones that we did here, they are just only neutral atom. They are just neutral atom. So like, for example, what I'm talking about is that, for example, now we can have water like this. You can have H2O like this. You know now that the oxygen will be the central atom, while the 2 hydrogen is bound with it. Now you can see now that oxygen is having 2 bond pair. So it's having 2 bond pair. So oxygen is having 2 bond pair now, 2 bond pair in this kind of molecules now. So it depends from when the atom are standing alone, like they are a neutral atom here, but they are a neutral atom here is different from when they join together with another element to form a molecule. So we are going to be discussing about this in my next class. Thank you.